Good afternoon, good morning, ladies and gentlemen. Welcome to another Cooking Call webinar. The topic for today is Make your enterprise applications ready for customers and mobile users. Open up, modernize, and secure your interfaces. My name is Alexey Balagansky. I'm a senior analyst at Cooking Call, and today I am joined by Jason Macy, who is CTO at Forum Systems. Before we begin, just a few words about Cooking Call. We are an analyst company working in the area of information security. We are providing enterprise IT research, advisory, decision support, and networking for IT. We are based in Europe, in Germany, but we have a global reach, including UK, United States, and especially APAC region. Speaking about networking, we do a lot of events, both in form of free webinars and real-world events as well. And our flagship event this year is the European Identity and Cloud Conference 2015, which will take place in May 5th to 8th in Munich, Germany. With over 600 IT experts from more than 35 countries around the world, this is definitely an event you should not miss. And as it's have been traditional for recent years, we are hosting a number of complimentary workshops at the first day of the conference. And one of these workshops this time will be the foundations of API security and API gateway technology, which will be attended by myself and Jason Macy as well. And if you are around Munich on May the 5th, you are welcome to join us. It does not cost anything, just come by. So some guidelines for the webinar. First of all, you are all muted centrally, you don't have to worry about it. We will record the webinar and make it available on our website probably tomorrow. You will all receive an email notification when it will be ready. Questions and answers section will be at the end, but you are welcome to submit your questions anytime using the special questions tool of the GoToWebinar control panel. So we will collect your questions and I will read them loud for Jason or maybe for myself to answer at the end. The agenda for today consists of 3 parts. First, I will provide a general introduction into the very area of APIs, their role in the modern connected business, and the challenges which your company will definitely be facing when trying to adopt, to become the part of this API economy. In the second part, I will hand over to Jason, and he will dive deeper into specific architecture details and technologies for API modernization. And as I said, there will be a Q&A session at the end. Please start submitting your questions as soon as you have them. And I would like to begin with a slide you probably have seen many times if you have attended any of our webinars. This is the probable computing Troika. Troika is, of course, a famous Russian horse carriage drawn by 3 horses. And these 3 horses are cloud computing, social computing, and mobile computing. These are 3 major IT trends which are driving innovation in the IT area now, and basically, although they are opening a huge amount of new business models for companies, new possibilities to interact, they are also stretching the scope of information security to the new limits. Basically, proliferation of mobile computing means that your customers can be accessing your services from any time, from any platform. Cloud computing means that your data or your business logic will probably be hosted somewhere beyond the perimeter of your company network. And social computing means that you will have to establish new connections to various new types of partners out there. And as I said, all this technological evolution is basically driven by business demand, which means that IT has to keep up. IT has to enable new technologies. It has to provide security. It has to basically, it always has a leading role in decisions like which technologies will be adopted by business. So to quote Lewis Carroll, you see it takes all the running you can do just to keep at the same place, and if you want to get somewhere else, you have to run at least twice as fast. Well, basically, what we observe now is that everything communicates. Companies, people, devices, and this new world of smart things, they all have to communicate. And how they communicate? Well, they have to communicate through established interfaces. So basically, the term API, which just a few years ago meant had a pure technical meaning known only to software developers, has suddenly become a lucrative business opportunity. Businesses want APIs, they want to open up their services to as many new audiences as possible, and we, the IT people, have to take care about a reliable and secure implementation. Just a couple of days ago, I was reading another article describing what here in Germany is called Industry 4.0, the new industrial revolution, which will totally change the way we work, the way we live, the way we communicate with our partners and customers and leads. It painted a beautiful new world full of capabilities and opportunities. However, as usual, it has forgotten to mention the new challenges and problems, and especially security and identity and trust-related issues. If I dare say that without security, instead of Industry 4.0, we can easily end up with Skynet 1.0. If we have a look into the past, I can safely say that the need to exchange structured data between heterogeneous and separated systems is as old as the networks themselves. There were many different approaches to the so-called distributed objects, RPC, DCOM, CORBA, and so on. But probably the first internet scale, the first attempt to implement it on the internet scale is the so-called SOAP, a Simple Object Access Protocol, which was the first standardized and formalized set of specifications to implement the service-oriented architecture, the paradigm of building loosely coupled systems based off the self-contained entities which belong to different ownership domains, and although they are exposing kind of formalized inputs and outputs, the actual implementation tails are usually hidden. Though the first attempt was SOAP. It was introduced in 1998. It was extremely well formalized and consisted of a large number of specifications defining different protocols, transports, whereas built-in security and other technologies for error handling, encryption, digital signatures, and so on. It was actually pretty successful. In a sense, many enterprises still use it a lot for their internal services or for their B2B services. However, it failed miserably when it came to opening the services to the consumer scale internet. One of the biggest problems, of course, was complexity. In order to support, in order to connect to such a service, a developer needs to do a lot of work. And another problem was pretty slow because the XML serialization used to transport the data back and forth is extremely redundant, and it doesn't scale well for large implementations. Therefore, the next attempt has been made a few years later. It's the so-called REST, representational state transfer. This is actually not a protocol at all. This is more like a common agreement on how to implement services. It was introduced, well, probably the first noticeable large implementation of REST API was made by Salesforce in 2000. but it really gained momentum in 2006 when many large companies like Facebook, Twitter, and Google came out with their services based on REST APIs. I mentioned it's not a protocol, it's just a style of implementing web services based on existing HTTP methods and URIs. It doesn't have any strict requirements regarding the data formats, but most popular ones are JSON or XML. It's very easy to implement, very lightweight, very scalable and high performance. Unfortunately, everything else is optional. So identity, security, and all the other services are not necessary. They are not built in. And this is why REST is essentially one. Now it's a de facto standard for implementing APIs on the internet, because developers are lazy and businesses are impatient to bring their APIs on the market as soon as possible, so they adopt REST. The only problem with it is that although creating a new REST API is very easy, converting your existing internal enterprise service to it isn't. First of all, most probably it's not based on the REST architecture. It's probably using some legacy or some internal transport messaging protocol, or maybe even SOAP. In any way, before making it available on the internet, it has to be somehow converted on the fly. And it has to be somehow refactored, probably. The different parts of different services have to be tailored and combined and merged. Something has to be masked. And all this has to function on the fly without losing any scalability and security. Now the next challenge is, of course, addressing different types of identity. Yes, as has been said many times already, making your business connected gives you a lot of new business opportunities. It gives you agility to adapt to new business models, to open up to new audiences, but you have to realize that supporting enterprise identities like your employees or business partners is completely different from supporting consumer identities, be it Facebook or any other social service logins, be it your customers or potential leads. There are different authentication methods and different strong authentication standards, tokens, smart cards, biometric devices. All this has to be taken care of before you even expose your service as an API. The problem, of course, that REST, as I said earlier, does not have any built-in security. Probably the only de facto standard for REST APIs is OAuth 2.0. It's probably the most popular authorization standard for consumer APIs. But as I said again, your internal enterprise service is probably based on a different standard, most probably SAML, which is the most popular authentication and authorization standard for enterprise solutions. So it means that there has to be some kind of service taking care of accepting different identity tokens, converting different authentication standards, supporting identity federation standards. So, without going into details, which I leave to Jason, I would say that you need some kind of a security token service deployed in your network to support identity services for your API. And then, of course, the access control becomes a completely different story. For your internal service, probably the old static role-based access control was enough because you only had a finite number of employees and a few external partners. But to manage different types of identities, you really have to make everything dynamic. Each decision whether to give a certain identity access to a certain API method. It has to be done in real time, in runtime, and it has to be based on the various types of context information. Of course, the good old roles, the attributes provided in claims, device type, geography, time of the day, you name it. All of this has to be taken into the decision process, and it has to be adaptive, agile, and flexible enough to be extended and changed as soon as new standards, as soon as new types of audience appear. So again, without diving deep into details, there is obviously a need for some kind of a policy management service running into your network, a centralized place for creating and enforcing these access control policies. And of course, you have to understand that implementing a REST API, you are basically opening a large front door directly into your corporate data, which is your most valuable and most highly protected asset. And since REST APIs are based on the same HTTP protocol, just like the normal websites, you have to address all of the same threats, denial of service attacks, SQL injections, malware, you name it. And there are, of course, new types of attacks which hackers are constantly developing, which are targeting specific protocols or data schemas or code injections which can disrupt your APIs. And again, you have to take care of caching, throttling, and other mechanisms to ensure availability of your service. And of course, security is something which people tend to forget at the design time, and this is especially true for REST APIs where security is basically optional. And although some developers would say, but we have the transport levels encryption, we have SSL. The problem is that SSL is not enough. It's not secure because if you're relying on an open source implementation like OpenSSL, you are basically vulnerable to multiple security holes. You know the stories of Heartbleed or Poodle or other attacks which have been described recently in the press. And of course, another problem is compliance. As soon as the data you are dealing with is somehow covered by compliance regulations with healthcare data, private information, financial transactions, and so on, you have to be certified, which means that your API has to be protected by strong certified encryption. It has to be monitored. It has to provide a complete audit trail, collect data for forensic analysis, and so on and so forth. So basically, although RESTful API is widely accepted as an easier alternative to SOAP, it looks like it's not that easy to publish your existing service as a RESTful API. Luckily, you don't have to take care of all these challenges yourselves. There are vendors, there are solutions which will support you on that way, and this is where I would like to hand over to Jason, who will provide you a deeper view into the specific principles and technologies for API modernization. Jason?
Thank you, Alexei. Yes, so I will share with you the follow-on information. Let me bring up my information here. Well, thank you for that, Alexei. It's a great segue into representing the challenges really that are out there to modernize and really make your applications ready for consumption, especially in the world of mobile and cloud. It's certainly a challenge. And what we're going to do is we're going to talk about how to solve that challenge, specifically what kind of technology we can use to do so. First, quick introduction is Forum Systems. We are the provider of the Forum Sentry API Security Gateway. which is the industry's only secure architecture gateway product with a FIT certified, network device protection profile certified, and U.S. Department of Defense certified technology. The focus of this technology is going to line up very nicely with some of the challenges that Alexei just identified, because the focus of API Security Gateway technology is integrated security, identity access control, single sign-on, and data mediation. And I'm going to talk about how all those come together to align with solving many of the challenges of API externalization and how to simplify that effort. So we were talking about making these enterprise applications ready, and Alexei gave some very nice introductions to the notion of APIs and the concept of APIs. Really, an API, in terms of looking at an enterprise application, which is usually a mobile app or a B2B integration point or portal or some data exchange that's happening, it's often based on some of the modern structured data formats like HTML, XML, SOAP, REST, and JSON. But the API really represents that access point, that intermediary, that interface to that service or data. It's the means by which to communicate, often with some additional capabilities, but representing itself as really that enterprise application, that interface to that enterprise application. So if we focus on that as the aspect of getting our enterprise application ready, then we can look at the notion of how APIs are truly the center point of integration and innovation. Across the spectrum of technologies today, the innovation curves are all evolved around the ability and necessity to interoperate, to work within different ecosystems, to be able to communicate with different infrastructure components, and all of that has very significant aspects of what we're going to talk about around identity and security. But it's important to note that the APIs truly are, they comprise the core of modern day innovation. That's how the evolution of standards and the evolution of many technologies has converged to enable this explosion of capability and innovation, which we see today in the landscape of computing. And so we want to look at these challenges that Alexei just highlighted in many ways around the enterprise application, or really if we focus that on the API challenges in terms of going back to those points that Alexei made around, okay, we have the authentication and SSO requirements as a component of APIs, and enterprise application access control, of course, making sure the right decisions are made, and then of course the cybersecurity component of looking at the threat vectors and the characteristic types of security threats that enabling communication to the application, via the API, ultimately poses those challenges. So we're going to take each of these and focus on how we can solve them. Enter the API security gateway concept. So with that notion of API accessibility, the portal or the window into communicating with that enterprise application, is where the API security gateway technology resides. It effectively wraps and presents that API as a representation of the enterprise application itself. So it's meant to be a seamless intermediary. It effectively is presenting that communication to the consumer exactly as if it's the endpoint communication. It is the API that represents that integration point. But then by having control over the communication pattern to wrap that and broker those communications on behalf of the client, we can now start to look at how to centralize and solve many of these challenges that Alexei just highlighted very nicely around those access, identity, and security requirements. And so that's where we focus on the core capabilities that this kind of technology provides, that the API security technology has embedded within it policy engines that are capable of doing many things around those specific areas: transport security, authentication, role-based access control, content-based access control, attribute-based access control, threat mitigation, data privacy, and data mediation. These are all encapsulated within a security container certified, so that the gateway itself is a security system by which these features and capabilities can be utilized within. So you have the combination of a secure platform that can be deployed on the network with confidence and the capabilities therein to leverage out of purpose-built technology that can do these things. So what does it mean to do these things? Let's talk about that a little further. Let's break it down to those core components of capability. And let's map that back to Alexei's challenges around what we need to actually achieve in order to facilitate agile APIs, to foster innovation and externalization of information, but have the capabilities around authentication, access control, and data security. And that lines up very, very nicely with core competencies of API security gateway technology, in that those are the mantras of that type of a gateway approach, which is unifying and combining identity access control and data security at one technology component so that you can centralize those decisions. So let's talk about the agility factor that goes into security and identity and how we can achieve that. It goes back to some of the points that Alexei made earlier around the different technologies, the different standards. We've talked about REST, we've talked about SOAP. So when we talk about unifying capability with regard to API security and identity and access control, we have to focus on the broad spectrum of different technologies and different data formats and different identity formats that that live on the networks that are a part of existing ecosystems. So when we focus on that, one key component of a solution that can provide for the identity management aspect is to be able to understand and consume all kinds of different identity token types. Now, fortunately, over the evolution of the last 10 or 15 years, a lot of standards have matured and evolved to be, framed within a pretty known set of token types. It's fairly broad still, but still framed within standards. So like in the SOAP world, you'll usually see username tokens or Kerberos tokens or X509 tokens or SAML tokens or digital signatures with embedded X509. So those are very standard ways within sort of SOAP and XML world to deliver identity credentials within the message. And then you've got your sort of RESTful and mobile and web portal world of protocol identities, like basic authentication, digest auth, form post authentication, cookie auth, X509 two-way authentication, are all mechanisms of identifying the consumer or the client that's coming in to make those requests. So we need to unify all of that within a technology component that can consume all of those things. So this is the core capability and competency of gateway technology that can unify and consume all these different formats and in fact translate from one to another. So from an interoperability perspective, from an API exposure perspective, now that same enterprise application can actually be exposed as an API in different ways, potentially on different identity token formats, so that you can extend a much broader landscape of consumers without having to worry about interoperability and other issues. Having the broadest spectrum of identity consumption capability gives you the highest ability to be agile about that business service, about that enterprise service, because ultimately then you can focus purely on what the service does rather than having to worry about all the different landscape of technologies that are to be consuming. So we want to be able to unify our identity consumption then provide those access control. The logical next step of identifying a user or a device or a system is to then provide those dynamic mechanisms that Alexei noted around access control. That includes often talking to some kind of IBM infrastructure system that contains password credentials, role information. This could be an LDAP, an Active Directory, a SiteMinder, a Tivoli, all the standard IBM systems out there, database, which ultimately, when those credentials are extracted, then communicate with one of those IBM systems for validating those credentials and then doing additional checks around roles. And here's the key. The gateway capability of combining data security with identity allows you to also look at the messages themselves, the information itself that's being presented to the API coming in as well as going back, so that we can focus access control not only just on trusted users and trusted roles, but more dynamically about the information also that's coming with that user and that's leaving the back out that API to that user. That's really a key aspect of access control, is also focusing on the data and the content affiliated with that user as a part of the access control dynamic analysis. And then obviously attributes in terms of the time of day, geolocations, where you're coming in from, all kinds of different conditions that are in fact dynamic in nature. And the philosophy of a gateway approach to this is that now you can unify that such that all those types of accesses to different APIs can make these decisions dynamically through policy design and policy implementation. And ultimately, our next step in that is we do certainly want the identity concepts of ensuring we know who's coming in and accessing these APIs, we control that and, through various access control. But ultimately, when these are cases of valid users and valid transactions, we want that experience to be seamless and unified across our APIs. And that's where the concept of federation comes in, where you'll see standards like SAML and OAuth as quite the two primary adopted solutions out there around delegated authentication and the ability by which to take those identity authentication and access control decisions and extend them to different parts of the transaction pattern, to different systems and different APIs, either within your own infrastructure or through shared relationships out in the cloud or other trading partners, where those strong authentication access control decisions that were made can be extended and delegated, so we can achieve what we call single sign-on, which is the ability to vet a user and to validate a user and then determine what that user can do across a bigger set of services and data, rather than just point services and enforcing credential authentication for every single access to every single different service. The goal is a more seamless, unified experience, especially in the mobile world and a web portal. You log into an online banking application, you want to go through all your various parts of that interface without having to re-authenticate every time. Those are things under the hood that gateway technologies facilitate by extending those base capabilities and credentials of access control and those checks to single sign-on capabilities. And again, primarily using schemes like cookies and SAML and OAuth are very, very popular means to achieve it, and very simplified means when you're using purpose-built technology that you don't have to write any code to achieve any of that. So we get to the point of identity federation, but we have to focus clearly on, as Alexei noted, the data security component of that. It's not enough to have a trusted user and access control checks without being concerned with the exposure of an API and the information threats that API externalization and application externalization ultimately lend itself to from a threat profile. So we look at security across really four primary areas when we're talking about enterprise applications and consuming them. First, we want to focus on allowing the appropriate kinds of content. So if we've got a RESTful service for a mobile app, we know it's going to be framed within some realm of expectation around, okay, maybe it's XML, maybe it's JSON, or URIs that are expected. But those are defined aspects of what the service infrastructure expects. We should be checking and validating that that information is aligned with what the infrastructure expects. Similarly, looking at information coming back out of that API from a request response perspective. Is that data aligned with what that API was expected to be sending back, or do we have a breach situation where we've got data leakage, a table dump, or something that's not in line with expectations? Can be enforced and should be enforced from a threat perspective, so you're not just allowing trusted users or validated users to have any accessibility characteristic whatsoever of any kind of data exchange. It should still align with what the actual application expects it should look like. And then, of course, there's the aspect of rates and sizes. There's certainly characteristics of users that should only have certain SLAs. There's certain characteristics of what your application service can do. If you expose that application service and have 10,000 consumers in the next week, can it sustain that? Is that a situation where you get oversaturated and the service cannot reliably perform? Well, those are rates that can be enforced at a gateway layer and preventing this oversaturation either by size, heuristics, or rates of access. Looking at things like antivirus and data and pattern recognition like SQL injection. These are all mechanisms to validate conformance and validity of information, of the data. At the same time, we're validating identity and access control so we can have a much more unified approach to that without having to worry about how to combine them in different ways with different architecture components that don't know about each of those capabilities. Similarly, when Alexi said SSL is not enough, clearly we know basically based on Heartbleed and other things that any C-based library has inherent vulnerabilities, so that the notion of open SSL has many problems, as we've seen. But even philosophically, the notion of SSL, it's just a peer-to-peer encryption mechanism. It does not apply for many aspects of modern-day applications because that data itself, XML and SOAP and JSON, is where all the data and information resides inside the messages. So we've got to look at message security in motion, as well as what we call at rest, or as that message moves around to different components through its life cycle. We want to consider encryption schemes and data level encryption to make sure the privacy of that information is always maintained throughout its life cycle. And transaction privacy is thus a big part of the data security model, depending on the kind of application and API exposure that we want to achieve. Similarly, we look at integrity. This is the signing of information. And you know, in the SOAP world, in the XML world, as Lexi noted, there's definitely many standards that have evolved as of OASIS and W3C around DSIG and signature verification. We're starting to see some cases in the RESTful world as well. With you know, places like Amazon S3 and EC2 and Eucalyptus, where there's where they have some concepts of signing of information using some hashing algorithms and other things that we often see. But ultimately, the goal is to define some mechanism of validation so that you can ensure integrity of information, meaning that when information leaves one point, it can be validated that at the consuming point that it hasn't been altered or tampered with. And so enforcing things like the protocols, the methods, schema information, and having signatures concepts are all ways in which to help ensure a high level of information insurance and integrity, which is an important part of business agility. You want to be able to do this business with all these different people, but you want to have the notion that the data it has maintained its integrity and hasn't been compromised. And then the accountability side of it goes back to some of what Alexei was discussing. You have to have real-time capabilities of monitoring. You have to have historical ability from a reporting and auditing perspective. And so the notion of externalizing enterprise applications isn't the concept of just each individual. It's rather aggregating that conceptually and logically at one architecture tier such that you can see and have visible all the kind of API calls, all the data communication, all of the information exchange that's going on centralized in your architecture. If you don't go with a philosophy, then you're looking at end mile logging mechanisms on end mile servers that have to aggregate in various different ways. It's very difficult to achieve a unified, accountable transaction philosophy without the design principle of a gateway approach. The gateway inherently gives you that through that approach of API brokering and thus a centralization of the information that can be logged and audited, which is a very important part of a security model. And then, of course, there's the data mediation capabilities, both at the protocol layer as well as the message layer. In order to have agile business practices, you don't want to have to go back to the enterprise application and try to rewrite adapters for every single kind of different client, every kind of different technology that you may want to integrate it with. That's not agile. And in many cases, it can't happen. Either through the fact that these are legacy applications that simply haven't got the capability, or it's not practical from a business perspective to try to do that. And this goes back to the philosophy of a gateway architecture approach. Those APIs can be presented as in different formats, even on different protocols, to the same exact enterprise service. So that the notion of APIs, as we discussed earlier, being that window into the service, also gives you that logical abstraction to now make a couple of different windows. So this one maybe is an XML API to this service, and maybe this other one's a JSON API to this service. Maybe we've got one over here that's an SFTP API, and another one that's an HTTP API. So the concept is that you can now present the consumption ability to those enterprise applications. Because we're considering the abstraction point of a gateway philosophy, we can also accomplish a lot of the mediation and a lot of the interoperability without having to go back to that actual application and change anything. All of this can be done without writing a single line of code. And so by unifying all of these concepts, we achieve what we want to achieve, which is business agility with integrated security capabilities. Across each of these different areas that I've just discussed, these all go together and fold back into that notion that we talked about earlier around all the capabilities that reside inside of the gateway to offload and centralize those key functions that we've noted as necessary components and ultimately some of the challenges that businesses face. But when we look at the ability by which to then leverage technology that integrates all of these capabilities directly and purposefully as a technology component that has been designed and purpose-built to achieve area of functionality, that alleviates the necessity of having to consider all the complexities of these parts of identity access control and data security, and rather just focus on the design principles and the rules of externalizing applications and let the technology do the heavy lifting and the work for you. And so that's really the concept and the premise of how we approach this area of application externalization and achieve the notions of centralizing identity access control and data security. It really lives at the border of information exchange. If you consider legacy security architecture of sort of traditional firewalls, WAFs, IDSs, and event monitoring systems, Your API security layer is effectively, your API exposure point is something that you also centralize at the information border. And that allows you to unify many of these aspects that we've discussed today, where we bring together the concepts of identity access control, SSO, full capabilities for SAML and OAuth schemes directly provided for by the technology without having to write any custom adapters or custom code, but rather present that to the external parties and the external consumers and simply broker those information exchanges on behalf of the client while still maintaining those very key modern concepts of data security, a protocol break, deep content inspection, validation, threat analytics, A/B scanning, and certainly performance acceleration, so that the purpose-built technology can do these things at very, very high speeds rather than trying to build these components yourself, which is very difficult and obviously often not performant and certainly not scalable for a long-term strategy. And so that's really the concept that we come at from a design philosophy as well as a technology perspective to align with various of those things that Alexei noted as challenges. We really face those head on and look at utilizing the concept both from an architecture philosophy of a gateway as well as clearly the necessity to have the embedded technology to achieve that. Is how we then accomplish the goal of enterprise application readiness. Thank you for your time, and I will open the floor and turn it back to Alexei for any questions or any comments from the attendees.
You can submit your questions anytime. You have the questions tool. Please keep them coming. And the first question is, so basically the very concept of a gateway introduces a single bottleneck into your infrastructure, right? So it's potentially, first of all, it's a single point where enormous amount of processing of various kinds occurs. So what about performance penalties or latencies like that? And the second part of it is, of course, what happens if the gateway itself breaks, or what happens when the gateway itself is hacked. So how do you ensure that nothing of that kind happens?
Great questions, both of them. I'll take each one one at a time. Let's look at the performance profile. So first of all, the performance is a very essential part of this, and there's various aspects that go into the performance profile. One is cryptography. Anytime you have PKI asymmetric cryptography around either SSL capabilities, digital signatures, encryption, decryption, those are very traditionally heavy lifting aspects. The gateways built from the ground up with these capabilities to achieve cryptographic acceleration and performant processing around all of these different capabilities. So the gateway technology is a closed system built with policies that have been designed to feed into what we call the data funnel flow for request and response transaction processing, designed by intent to achieve much higher transaction speeds. You achieve those speeds because you're actually reducing the burden on many of your other existing components by centralizing these roles at the gateway. I'll give you a great example. Identity. Most traditional approaches to identity are agent-based approaches that you have agents sprinkled about on n-mile services. They have to communicate back and forth to an IDM policy server. One service knows nothing of the other. You get huge I/O latency implications and a glass ceiling on the ability to achieve a true scalable architecture. A gateway approach is centralizing that decision point, knowing the APIs that are all related to those identity credentials, intelligent caching to significantly reduce by often an order of magnitude the I/O latency imposed by continual communications back and forth to identity policy servers. So through many aspects, the gateway, and we have lots and lots of deployments globally that can speak to this, that facilitate a much actually faster transaction path because you're leveraging technology designed to optimize those processing aspects. To the second point, a very key point. How could you possibly adopt a gateway if you're concerned that the gateway could be the point of being compromised? I can't tell you how great it is to hear that question, because it's the foundation of us as a company and organization over 14 years in the industry. We've achieved these certifications of FIPS and NDPP and U.S. Department of Defense through our rigid adherence to the assurance of the architecture capabilities of this gateway are designed such that it can't be compromised. And it's gone through some of the most rigid independent certification and penetration tests, as you can imagine, military-grade tests, years and years of penetration testing. We are in the critical path of about 80% of the United States credit card transaction processing, about 40% of Western Europe. We do all the United States tax returns. We're in about 8 UK agencies with very, very high performance requirements. So these are systems that have been adopted and run today in some of the most mission-critical environments that you can imagine. They're designed by intent and architected by intent to be able to be deployed as a centralized component without having the exposure compromise. And this is a difference that you'll see. This is why we call our solution an API security gateway. Others will call their solutions an API gateway. The difference is how secure is your gateway. If your gateway is not secure, you can't do the things that I have discussed today, because it itself then becomes a point of compromise, and you can't deploy it at the information border. You have to deploy it deeper in the enterprise with lots of layers of protection above it, which removes those concepts of agility that we've discussed today. So that's a core difference between an API security gateway and an API gateway.
Well, I can just say that I cannot really agree more with that, because way too many companies start thinking about security too late and not building the security into your the whole life cycle of your product, so to say, is essentially a big mistake, because a gateway has to be the most secure part of your whole infrastructure. Okay, let me remind you again, please send your question through the question tool. And here is one. Can you please provide some examples of content-based access control use cases?
Absolutely. I'll provide a couple good ones. Probably a good one to talk about is, so in the United States, the entire revenue stream of the U.S. government is facilitated through electronic tax filing. The Forum Sentry devices have been at the perimeter of the United States Treasury since inception of that program. That is an electronic means by which every citizen of the United States files taxes and tax return information. That data actually gets transposed into a SOAP document with attachments. That SOAP document with attachments contains very specific information about each tax filer, and it has to be correlated across many different characteristics of validation, who the authenticating, multi-factor authentication to designate the user, source of transaction, and then taking that and correlating it to the information inside of the request pattern, which is effectively the tax return information, such that the data itself has to conform not only to the requirements of the service, but also conform to those capabilities that have been associated and those roles that have been associated with the user. So that's one example. Another good example is the oldest railway system in the world is in the UK. It's now managed by Network Rail. If any of you have ever traveled to the UK and rode the rail system, that infrastructure is actually protected by Forum Sentry technology. And all of the integrity rail checks that are done across 30,000 miles of track are actually facilitated and brokered through Sentry technology. We did this about 2 years ago as a result of the government mandate that required integrity checks on the rail system. But they had an old legacy system that couldn't facilitate that. It used to do it by paper and pen. and they were not going to be able to achieve that government mandate of having those integrity checks each year. So we worked with Network Rail to provide a REST mobile application, iPhone application, called basically that provided role-based capabilities to field personnel to upload integrity information and checks based on their designated levels of field personnel that validated various things at the gateway. You've got to now look at the data payload. If you're sending in a report about either a good track or a bad track, you have to be the right kind of person, first of all, field personnel that can do that. So you've got to identify that user and that phone as an eligible mechanism. And then you have to make sure that the data being submitted, first of all, is conformant, and second of all, aligns and matches up to the role of the user that's allowed to. You certainly don't want a rogue user talking about a track or providing bogus data about an integrity check of a rail system. So those are a couple just simple off the top of my head examples. I've got lots of others, but those are all the characteristics of wanting to combine the notion of who you are, where you're coming from, and what you're bringing with you. It's probably best correlated with airport security. When you go to airport security, you've got to identify yourself, they check your bag, they check your ticket. Same concept with the gateway and APIs. You want to check all those things at the same point of communication rather than at different points in the transaction path.
Okay, well, thank you very much. And since we are almost at the top of the hour and it looks like there will be no further questions, let me just quickly draw your attention to our related research documents, which you can find on our website, kubingercall.com. Especially, we have one multi-vendor report in the works and will be published pretty soon concerning the topic of API security management. And I assure you that there will be some pretty interesting findings in that document. And with that, I can only say thank you very much, Jason, for giving such an interesting presentation. Thanks for the audience. And I hope to see you again in one of our future webinars, or maybe at our API workshop in Munich. Thank you and goodbye.